first couple articles in this book, Psychological Optics by Samuel Renshaw, published by Forgotten Books. And the first two articles are called What Can Experimental Psychology Contribute to Optometry? That's the first one. And the second one is The Importance of Point of View. And I'll post the rest of the table of contents, which I'll make videos about later. Okay. What can experimental psychology contribute to optometry? October 1939 by Samuel Renshaw, M.A., Ph.D., Ohio State University, published as part of the Optometric Extension Program, copyright 1939, Duncan, Oklahoma, Volume 1, Number 1. Vision and visual problems are common ground for many divisions of science. In this first paper of a series of talks to optometrists, it shall be our job to show how psychology plays its part. Physics, physiology, and neurology describe what is known about the eye, how it is arranged for the reception of changes in the patterns of light, and how these physical events in the retina produce impulses in the sensory nerve fibers. These impulses then pass to the brain and onto certain of the effector organs of the body, muscles and glands. From the effectors, other proprioceptive organs pick up results of the contraction or secretion and relay the impulses back to the cord and brain. Thus is completed the organic circuit. Volumes could be written by scientists summarizing our present knowledge about each phase of this most interesting and important process. Other volumes could be written on the numerous problems relating to vision, which are poorly understood today, if at all. Each of the sciences makes its own studies of the process, working from its own point of view, using its own tools, devices, and methods. No one tells or can tell the complete story. Each borrows much from its fellows. Altogether, they can give the most complete and truthful picture of the process available to any human being. Most optometrists are required to know and stand examinations on the physical and mathematical principles involved in the laws of lenses, geometrical and physiological optics, etc. The anatomy and histology of the eye is taught in all the leading schools. Psychological optics, on the other hand, is almost universally neglected. Yet it is a most important factor in every case seen by the practicing optometrist. In the most simple way possible, let us put it this way. People come to you but for one purpose: to secure for themselves clear and comfortable vision. No matter how exacting your instrumentation, or how clever or how skillful your diagnosis, prescription, or treatment, your lenses will not be worn if they do not yield to the patient comfortable, clear vision. Now, just what constitutes comfortable, clear vision? Can it be lacking and the patient shows significant corneal or lenticular aberrations? Can it be lacking in accommodation and convergence, yet be entirely adequate? Can vision be uncomfortable and not clearly and sharply resolved when all the mechanical factors of vision are in such order that the patient should see comfortably and well? I am certain that from your experience you can readily answer all these questions in the affirmative. And this leads us at once to our first generalization. Each of the things which will help us understand better what psychological optics is, what we can do about it, and what it can do for us. This generalization is that a large part of seeing is not done with the eyes at all. Vision draws heavily upon the other senses, modalities, particularly the skin, the kinesthetics, muscle, tendon, and joint sense, and the ears. Whenever I say, "This iron ship's anchor looks so heavy I doubt if I can move it from the sand," I am speaking figuratively. Nothing ever really looks heavy. Heavy is a judgment we make it when we try to overcome the inertia of a mass by the shortening of certain groups of our muscles. Similarly, other senses borrow from vision. Much of what we hear derives from watching the movements of a speaker's lips, his gestures, the play of his facial muscles. Since the afferent impulses from sight, hearing, and touch are all correlated in the midbrain, And since in all the ordinary affairs of everyday life the perceiving of things is participated in by almost all of our sensory motor functions, we hear more and more discussions of the unity of the senses, and less about each one, separately considered from the others. When you read or are told that 85% of all your impressions come through the eyes, set it down as a statement which is false, unproven, and unprovable. Eyes are important, most certainly, but there is no good comparing why we should tell untruths about them. But there's no good reason why we should tell untruths about them. It is a psychological fact that everyone sees more than is furnished by stimulus objects. This is another way of saying that the observer contributes much to the process set up by the various patterns impinging upon the retinae. We not only thus supplement what is physically present to be seen, but it is likewise a well-known fact that we may suppress large portions of the field comprising the stimulus pattern. Let us take, for example, the case reported by Dr. Purdy, a prominent psychologist who has contributed much to psychological optics. Psychological Review, 1935 through 1936. A girl, on being shown 3 small dots in the shape of a triangle and asked to fixate a 4th dot in the center, reported the 3 dots ran toward the center and fused into a single dot at the point of fixation. No matter what interpretation is placed upon this phenomenal experience, one fact is clear. The retinae are being stimulated continuously by the 3 dots. The fact that they do not in experience remain in the same relative position as they are found in the retina indicates that a process of simplification, suppression, or reduction of detail in the stimulus pattern may be added to the experience by the observer himself. Instances of this sort clearly indicate that psychological optics has its own problems. Many interesting and important similar instances could be cited to show that no complete account of seeing can be rendered without the assistance of the description of the psychological aspects of the process. Interesting also is the fact that we see things not on the retina, not in the brain, but out there in space. Why should this be? Can we find the answer to this question in textbooks dealing with physics or geometric optics? Can we find it in physiology or neurology? Then obviously we must be dealing here with a fundamental problem which belongs specifically to the field of psychological optics. The position in space of an object, its size, shape, relative brightness, color, motion, etc. are seen by an observer in a way not predictable by anything we may deduce from the size, position, shape, etc. of the hypothetical retinal image. Before their habits are fixed, most children are able to read print upside down as well as right side up. Stratton, Patterson, Ewart, and others have worn prisms inverting the visual. Stratton, Patterson, Ewart, and others have worn prisms inverting the visual, and that cross and longitudinal relations in the optic bundle represent a further distortion of the real object out there. Then why should not a visitor from Mars inquiring about Earth creatures and their eyes reasonably ask, how can you see as a continuous unitary straight line this solid black line on a white background? The appeal again must be to psychology. Nothing that we can find from our knowledge of the structure of the retina, the optic bundle, or the nature of the conduction of impulses in nerve can possibly give us the answer. And if in the light of everything that we know about rods and cones, about the nature of nerve conduction, etc., if in the light of everything that we know about the rods and cones, about the nature of nerve conduction, etc., is taken into consideration, and we try to answer the question, what is the physical mechanism which enables us to discriminate small differences in the intensity of illumination? What is the physical mechanism which enables us to discriminate small differences in the intensity of illumination? We are forced to conclude that no satisfactory answer to this question can be found. The only explanation which seems to fit the facts must involve psychological considerations. If our friend from Mars is an exceedingly inquisitive fellow, he would undoubtedly list many additional questions about simple cases of seeing, such as the following. Before me lies a small pad of paper 3 inches by 5 inches on the extreme right corner of my desk. I know that the angles of this pad are all right angles, but if I want to draw for my friend from Mars a picture representing what I see as I look at the pad, I do not draw 4 right angles. I can only see the pad as comprising 4 right angles under a very narrow set of conditions. This is to say, it will have this appearance when it is directly in front of my eyes and on the line of sight, and when it is seen under the influence of certain background and foreground relations. In fact, the size, angular relations, and relative positions of the retinal image do not vary in any constant way with phenomenal experience. Imagine what would happen if we always saw things and reacted to them as they appear on the retina. The 4 inner plates to the right of the right of you then become 4 increasing ellipses, the final one being much longer than wide. Ours would be the fate of the inexperienced child who, on seeing an artist drawing, exclaimed, "See elliptical wheels on the cart," and then naturally fell to wondering what would happen, especially since the rear ones were larger than the front ones, if the thing should start. The fact that if vision were a direct copying process, life and experience would be for us a hopeless confusion seems to be ground enough to justify our serious attention to the problems and accomplishments of psychological optics. In subsequent papers, these informal talks will deal especially with a wide variety of problems arising out of the facts derived from the psychological study of seeing. We shall deal with questions relating to why things look as they do, to stereoscopic and pseudoscopic vision, and to the seeing of the third dimension, to visual apparent movement, to brightness discrimination and the problem of intensity, daylight and twilight vision and visibility curve, color vision and color anomalies, visual perception and the problem of isomorphism, visual acuity and its measurement, the retention and recall of complex visual impressions, and on the training of the eye to see. We shall hope to show as we go along that scores of able workers in experimental psychology in various parts of the world have accumulated a large body of facts, and that these facts are of the utmost practical importance to optometrists and to all others interested in the science of seeing. It is safe to predict the future developments in optometry will come to deal with more and more with the psychological aspects of visual insufficiency. We shall hope that this series of short papers may serve to direct your thinking and study along those lines. No, Pat, don't study optometry. Don't become an optometrist. Okay. This is The Importance of Point of View, November 1939, Volume 1, Number 2, by Samuel Renshaw, M.A., Ph.D. Before undertaking an examination of results in theory in psychological optics, there are some very necessary preliminaries with which we must deal. Excellent grammar. Were we to fail to do this, no matter what our intention and efforts, we should not be very successful in making clear the meaning of the principal accomplishments in this field. I refer to the primary importance of point of view. Progress in any division of science generally follows from the setting up of a set of postulates. These serve to set the limits of our operations and assist in the proper formulation of problems and methods. Chemists at one time, worked on the basis of a set of postulates which held that everything was some combination of 4 elements: earth, air, fire, and water. There was another element too, but very little was openly expressed about it. Logic and speculation supplied a hypothetical framework of affinities and repulsions among certain of the elements. This was the historic age of alchemy. Very little progress was made in gaining a better understanding of the chemical world, so long as the limiting concepts of the alchemists were accepted and followed. And in fact, chemistry was not chemistry at all, except perhaps in name. One of the many deficiencies of such an approach to the study of things and processes in nature lies in the fact that mysticism and teleological expletives are introduced in order to make the assumptions cover the observed cases. Thinking becomes finalized, classificatory. Like the old instinct doctrine, name and classify and act and your problem is solved. No further investigation is needed or wanted. The armchair debate and easy common sense logic take the place of the laboratory and rigid proofs. It took the chemists a century or more to free themselves of the blinding hampering influences of the earlier wrong point of view, but by systematically revising their total concepts, refining and extending methods, the creation of better working tools, the science of chemistry emerged from alchemy and natural philosophy, and in so doing produce results which have revolutionized the economic order. Modern chemistry has radically changed the whole picture in the study of the physiology of body functions. Each year its horizon widens and the scope of its service becomes greater and more important. Psychology and the biological groups are gradually emerging from their own infancy, the age of poorly chosen postulates, pseudo-problems, confusions, and inconsistency. If we inquire in the general population, ignorance of what the body is, how it is constituted, and how it works, i.e., of anatomy, histology, embryology, neurology, and physiology, is appalling. Common and widespread beliefs and superstitions as to the causation of disease and kinds of cures astonish us as we hear them proposed in all seriousness. Nor does the uneducated have a monopoly on ignorance and wrong point of view in such matters. Truly it is brought home to us many times that a little learning is a dangerous thing. These people can vote, legislate, and propagandize dangerous half-truths which someone has said are worse than deliberate lies. If the hypothetical average man, who never exists, is obscure on a fundamental matters of astronomy, economics, anatomy, bacteriology, etc., what of his knowledge, insight, and skill in the mental realm? Many a college junior, when asked what is psychology, answers glibly, the science of the behavior of living things. If you then ask what is behavior, and demand clear, precise, and verifiable statements, you are generally rewarded by a look of astonishment and a strong preference not to push the matter any further. And college juniors represent about the top 3% of our population as far as affairs of the intellect go. They are the embryo policymakers and pace setters of the next decade or two. It is quite evident that here we find the importance of viewpoint doubly emphasized. To try to represent to a layman, untrained and wrongly biased, a resume of recent work on such problems as space perception, for example, is almost a hopeless undertaking. This is particularly true when the bias contains a set of easy, logical to him explanations gathered from indiscriminate sources. It is a pioneering job to divest the soil of these often firmly rooted weeds in order to prepare for it the tested seeds of fruitful science. Later we shall return to this question of point of view in psychology. It touches optometry the same as everything else. I dare say that after very brief search I could find you numerous persons convinced the eyes are literally the windows of the soul, and still more numerous others who think of vision as a simple mechanism, process, and nickel in the slot sort of thing. Pictures on the retina and the same pictures somehow projected in the brain. If you casually mention the facts shown by recent research that in uniform illumination as a pattern of light falls upon the retina, some of the photosensitive cells only fire upon the cessation of or sufficient reduction in the intensity of the light. Others fire, first in a burst and then settle to a slower frequency throughout the duration of the excitation. This later type must give us the basis of all differences of photometric intensities and therefore play a primary role in the resolving power of the eye, form discrimination, etc. Only 20% of the photosensitive cells are discharging during continuous stimulation, and the frequency of the afferent volleys of ions vary with changes in intensity of illumination from about 5 to 150 to 200 per second in the human. And to this the fact that the retina themselves are a region of transformation, so that it is impossible to regard the thing seen out there as a direct projection of the light pattern. The response to this, and more of similar facts, is usually again a look of incredulity and astonishment, and often a quick shift in the conversation to safer ground. Science is not just a method of massing and accumulating facts, which an Arabian scholar once called the idlest of superstitions, but it is an orderly and systematic arrangement of the pieces so that the puzzle picture is complete, unitary, and has meaning. This is always the most difficult part of scientific work. James one time called it thinking things together, not out of the whole cloth, but produced by rigorous sifting and checking. Without the guiding help of a proper and appropriate point of view, this constructive and creative step is made difficult or impossible. The expansion of basic concepts has completely transformed physics in our own generation, and the result are discoveries of the greatest importance to the present and future. A hasty examination of the history of the inductive sciences convinces one of the primary importance of viewpoint. We must profit by these hard-won lessons of the past if we are to travel far on the road to understanding in our short lives, for time is fleeting, and there are no shortcuts or royal roads. One of the greatest advancements lies in the fact that all the various divisions of science are beginning to speak the same language and therefore to understand each other. Field dynamics, which has done so much for physics and chemistry, is beginning to do the same thing in biology and psychology. If atomism would not do there, we may rightfully seek out its inherent limitations as it applies to our own work and interests. A scientist should make every effort to keep open-minded and be ready to change his ways of thinking, his concepts of problems and methods as experiences and broader, clearer views and be ready to change his ways of thinking, his concepts of problems and methods as experience and broader, clearer views grow and develop. He must shun bias and cultivate a readiness to abide by the verdict of carefully made experiments, letting the chips fall where they may. It is easy to cite instances of the incapability of man trained in one field to appreciate or to form valid judgments about the subject matter and methods of another. It is, too, the failure to see the forest for the trees in one's own sphere. One of the most dismal lectures I ever listened to was delivered by a world-famous physicist talking, as would the rankest amateur, about the workings of the mind. One should earn the right to have and voice opinions. Serious attention to either approbation or criticism should not be given until we have calibrated the reporter. We must first ask, is the judgment competent? And the judgment can only be competent if it is backed by requisite training, insight, experience, and skill. These things are never given, but must be won. One can fully expect that there are those who will always regard the field of phenomenal vision or seeing as something curious, perhaps of passing interest, but not for them. They will prefer to stick to the pointer readings of their instruments to 0.1 or even 0.01 diopter. The fact that the rules often does not trouble them. Can it be that optometry has waiting for it just around the corner a vast, new and explored field? That in the years to come, advances along these lines will completely transform instruments, techniques, and even the legal and societal status of your profession? It will be possible to detail here practical illustrations of the dramatic success of a number of your colleagues in the treatment of non-refractive cases of poor vision, when, for example, a serious squint is corrected permanently without either lenses or surgery, not once but in 2,000 cases, by comparatively simple technique, and when this technique can be taught to others so they too can produce the same result, even the most skeptical must face the facts. We do not know but a few of the great possibilities in this field. Points of view are bound to differ, to be in the continual process of making, unmaking, and remaking. It is healthy for any field to have the constant challenges, checks, and proofs resulting from these differences of attitude and viewpoint. It would take a sizable book to set forth the whole theoretical framework in which the many problems relating to seeing are to be handled. Naturally, all would not agree with the postulates thus set up. But no other satisfactory method has been found other than to try out tentative ones and to depend upon the results of careful investigation to verify them or to start over and produce a better set. In approaching the study of vision and visual processes, we must come to a decision as to whether we shall regard and study them as a molar or as a molecular process. If we take the molecular point of view, we shall try to analyze the processes into their elementary constituents, breaking them down into their simplest forms and functions. We shall study seeing by learning all we can about light, photochemistry, neurology and histology of the receptors, nervous and non-nervous conduction, etc. Critics of this procedure maintain that we can never approach a true description of seeing by this path, that such an analysis destroys the very thing we are seeking, that once we have described and measured the elements, we have contributed little or nothing to the proper understanding proper understanding and functional properties of the whole, no matter how detailed and precise our knowledge of the separate independent parts. The molar attack is the other way around. It holds that the whole is the primary reality. Wholes are not made up of independent parts, because parts are only independent because we make them so by an arbitrary process of analysis and classification. When we dismember a complex and isolated part, we disrupt oft-times the delicately balanced interrelations and create artifact and unreality. A frog's gastrochemical muscle is a moist chamber. Electrically stimulated will shorten and record its track on a kymograph. It is insisted that the same muscle under the intact skin and fascia, supplied with blood and lymph, and the natural nerve supply, behaves in quite a different fashion, especially if the frog must leap for his life or outdo a competitor in the courtship arts. Plants build cells, not cells plants, said a pioneer botanist many years ago. This is the cell theory versus the organismic theory in biology. Which road shall we take? We often hear that such questions are academic and impractical. It is said that one can just as well straddle or disregard the issues, thus take the so-called eclectic position. This kind of thing leads only to muddled thinking and to inadequate, uncontrolled, and inconclusive experimentation. A little consideration will show that both the kinds of problems and methods, and hence the value of the end products, inhere in this all-important first step, the clearest formulation of the basic plan or viewpoint we can achieve. When we do this, we save ourselves from much wasted effort, from many fallacies. Fake cures, devices, and principles cannot thrive in the light of honest and competent search for the truth. False beliefs, palmistry, and phrenology, and selecting assistance on the basis of skin texture, coloring, and the like are given their due just promptly. Careful work has shown that such a thing as courage, invaluable in war, cannot be predicted from any physical characteristic. So it is with honesty, intelligence of any other form of behavior. Consult the work of the Galton Laboratory in the files of Biometrica, or the Sigma Z lectures by Harris, Jackson, Patterson, and Scammon at the University of Minnesota in 1930, if you wish the evidence. In subsequent papers, we will talk about the things which may be more interesting, but certainly not more important. The taller the building, the deeper and firmer must be the foundation. Take stock of your viewpoint. Take stock of your viewpoint. It will pay good dividends in professional growth and satisfaction.